I feel like we've all had that exact moment. You finally drag yourself to the bathroom mirror after just a completely grueling, high-stress week.
Oh, yeah. The Friday night mirror check.
Exactly. Maybe you were battling like wild deadlines at work, or you were up all night with a sick kid, just carrying the weight of the world, basically.
Right.
And you look at your reflection, your skin just looks dull. Or maybe you've broken out, and you swear you have somehow aged 5 years in 5 days.
It's universally relatable, honestly.
Right. And it is so easy to just splash some water on your face and dismiss it, like, oh, I'm just looking tired.
Yeah, we totally write it off.
But we are actually looking at something much deeper. There is this profound, measurable biological war happening right under the surface of your skin.
There really is. I mean, we tend to think of stress as this uh, abstract mental burden, something that just lives in our heads.
Right? Just a feeling.
Yeah. Exactly. But on a cellular level, stress is a physical event with very physical casualties. And the data we are looking at today fundamentally shifts how we understand that exhaustion. We're looking at how our biological stress response actually alters the integrity, the healing capacity, and the actual age of our dermal tissue.
Okay, let's unpack this. Because you might think your brain is the only thing having a panic attack, but the research shows a completely different reality.
It really does.
So our mission today, we are custom tailoring this deep dive to figure out a really fascinating question. Can stress hormones actually affect our collagen response?
And we've got some incredible clinical studies and molecular biology research to pull from.
Yeah, we're going to explore the cortisol-collagen connection, how our skin acts like a second brain, the startling impact on wound healing, and eventually look at the molecular and lifestyle interventions proven to reverse the damage.
It's a really comprehensive roadmap.
So before we get into how our skin's foundation gets destroyed, I really want to understand where the stress is coming from. Because, I always thought cortisol, the main stress hormone, was strictly an adrenal thing.
Well, yeah, that is the traditional model we are taught in biology class. Your brain perceives a threat, right? Say, a looming presentation or a near miss in traffic.
Sure.
Your hypothalamus signals your pituitary gland, which then signals your adrenal glands, which sit right above your kidneys.
And those pump the cortisol.
Right, they pump cortisol into your bloodstream to initiate a systemic fight-or-flight response.
Yeah.
It's the classic HPA axis.
The alarm system for the entire body. So my blood just carries that cortisol everywhere, including to my skin.
It does, yes.
Mm-hmm.
But the sources we are analyzing today highlight a completely separate, almost rogue system.
Rogue system.
Yeah. The skin doesn't just passively wait around for cortisol to arrive from the adrenal glands. It turns out the skin has its own fully functional, localized equivalent to that entire HPA axis.
Wait, hold on. Are you saying my skin is manufacturing its own stress hormones?
Yes. What's fascinating here is that the individual cells in your skin are highly specialized miniature factories.
Seriously?
Yeah. Your epidermal keratinocytes, which make up your skin barrier, and your melanocytes, which produce pigment, even your sebocytes, which produce oil.
Okay.
Every single one of these cell types can synthesize and locally produce their own cortisol in response to environmental or psychological stress.
I am genuinely struggling to wrap my head around that. Our skin is out here acting like an independent stress response organ.
It really is. And this localized production means the skin has a built-in mechanism to generate cortisol right at the surface level.
So it doesn't even need the brain to tell it to panic.
Exactly. Even if your overall systemic mental stress begins to drop, say you finally finish that big project and your adrenal glands calm down, your skin can still be locked in its own localized panic attack. It keeps generating cortisol, which sets the stage for very localized damage.
Well, that perfectly explains why a stress breakout, or that hollow, tired skin look, lingers for a week after the stressful event is already over.
Right, the skin hasn't gotten the memo yet.
So now that we know the skin is literally flooded with cortisol, both from the systemic bloodstream and from its own local factories, let's look at the collateral damage. What is all this cortisol actually doing to our collagen?
Well, to appreciate the damage, we should probably look at the architecture of healthy skin first.
Okay, let's picture it.
In a young, healthy dermal layer, the tissue is tightly packed with a beautifully organized meshwork of collagen. About 80% of this is type I collagen.
And type I is the strong stuff, right?
Exactly. It acts like the main structural steel beams providing tensile strength. And another 15% is type 3 collagen, which provides the softer elasticity.
So together, they keep everything firm, elastic, and bouncy, like the scaffolding that holds the house up.
Perfect analogy. But when cortisol floods that tissue, it attacks that scaffolding on two completely different fronts.
Two fronts. Okay, what's the first one?
The first front is active destruction. Excess cortisol acts as a trigger to activate specific enzymes in the skin called matrix metalloproteinases.
Oh,
Right,
MMPs.
MMPs.
What are those doing exactly?
Think of MMPs as highly aggressive cellular scissors.
Ouch.
Yeah. Under normal conditions, they just help with minor tissue remodeling. But when cortisol turns them on en masse, they roam around the dermal layer and actively chew up and break down your existing healthy collagen and elastin fibers.
They are snipping the structural steel beams.
Exactly.
So it's like a wrecking ball hitting a building, just actively dismantling what is already there.
A wrecking ball, sure. But imagine the guy operating the wrecking ball also locked the gates to the construction site and then fired all the workers trying to bring in replacement steel.
Oh, wow.
Yeah, that is the second front of the cortisol war. It interferes with the signals your skin desperately needs to build new collagen.
How bad is the interference?
The clinical studies show that cortisol can reduce new collagen synthesis by up to 70%.
70%. That is a massive drop in production.
It really is.
How is a hormone shutting down the construction crew so effectively?
It happens through the inhibition of a very specific pathway called TGF-beta signaling.
TGF-beta.
Right, transforming growth factor beta. In simple terms, it is the master regulator, kind of like the foreman of your extracellular matrix.
Okay.
It sends the signal to your fibroblasts, which are the cellular construction workers, to start depositing new collagen. And cortisol specifically suppresses that TGF-beta.
So the foreman's radio is essentially unplugged. The fibroblasts never even get the order to start building.
You just sit dormant. Meanwhile, those MMPs are tearing the existing house down around them.
That is brutal.
And this dual assault isn't just a temporary cosmetic setback where you look a little tired for a few days. The research shows that this mechanism fundamentally alters the biological age of your tissue.
Which brings us to a really uncomfortable concept. We aren't just talking about looking older. We're talking about cellular time travel in the worst way possible.
Yeah, we have to look at the groundbreaking research by Nobel laureate Elizabeth Blackburn here.
Oh, the telomere research.
Exactly. Her team investigated how chronic stress affects cellular aging by looking at telomeres, which are the protective caps on the ends of our DNA strands, kind of like the plastic tips on the ends of your shoelaces that keep them from fraying.
And as cells divide over our lifetime, those plastic tips naturally get shorter and shorter, right?
They do. But Blackburn's research found that women under chronic, high psychological stress had telomeres that were significantly shorter than unstressed women of the exact same age.
How much shorter?
Well, their cells showed signs of biological cellular aging equivalent to over a decade beyond their actual chronological age.
Well, that is incredibly depressing. You could be 30 years old, but your stressed out cells are behaving like they belong to a 40-year-old?
It's intense. And to see how this plays out specifically in the skin, researchers compared human dermal fibroblasts in a lab setting.
Okay, what did they find?
They looked at young cells, which they call passage 5 cells, meaning they've only divided a few times and are very fresh. And they compared them to older senescent fibroblasts, known as passage 25 cells.
Senescent just meaning cells that have deteriorated with age, like they've stopped dividing but refused to die, kind of like zombie cells just hanging around the tissue.
That's a great way to put it, yeah, zombie cells. When they compared these fresh passage 5 cells to the senescent passage 25 cells, they found a critical difference in how they handle stress.
Which was?
The older cells had developed considerably higher levels of glucocorticoid receptors, or GR.
What are those?
These are the specific docking stations on the surface of the cell that cortisol binds to in order to cause damage.
Okay, wait, let me make sure I'm connecting the dots here. So what does this all mean for the listener? Are you saying that as we get older, our skin physically grows more receptors for stress, making us even more vulnerable to cortisol?
Yes, that is exactly it. The data strongly implies that senescent cells become hypersusceptible to cortisol.
Wow.
It creates this brutal compounding cycle. Chronic stress ages the skin cells prematurely by shortening those telomeres. And as those skin cells age, they grow more receptors.
Making them vastly more sensitive and reactive to the next wave of stress.
Precisely.
So when you're 22, you can pull an all-nighter, stress over an exam, and your skin bounces back by noon.
Right.
But at 35, that same all-nighter leaves you looking hollow for a full week because your older cells literally have more receptors soaking up the cortisol.
The vulnerability definitely increases with time. But we really need to look beyond the mirror for a moment here,
How so?
because this loss of collagen and cellular aging isn't just about wrinkles or sagging. Collagen is the essential foundational building block for tissue repair.
Oh, right. If collagen is the scaffolding for keeping a face looking young, isn't it also the scaffolding for patching up actual injuries?
It is.
What happens to a physical cut or a wound when cortisol fires the construction workers?
The breakdown of wound healing under stress is actually one of the most rigorously documented phenomena in psychoneuroimmunology.
Really?
Yeah, the clinical numbers are stark.
Hmm.
Researchers conducted a study looking at individuals acting as full-time caregivers for loved ones with dementia.
Oh, wow. That is a demographic experiencing severe, ongoing, chronic psychological stress, a very heavy, very real burden.
Absolutely.
How did they measure their physical healing?
They gave these caregivers, along with a control group of non-caregivers, a standardized punch biopsy wound.
A punch biopsy.
Yeah, it's a very common dermatological procedure. They use a tiny, precise circular medical instrument to remove a small core of skin from the arm.
Okay, so it allows researchers to measure exactly how long a uniform wound takes to heal under highly controlled conditions.
Exactly. Everyone has the exact same baseline injury.
So what happened?
The caregivers took 24% longer to heal that exact same wound compared to the non-caregivers.
24%.
Yes. In practical terms, that translated to 9 extra days of carrying an open, unhealed wound on their arm simply because their bodies were flooded with chronic stress hormones.
9 extra days. That is staggering. But I imagine listeners are wondering about less extreme scenarios, like what if you aren't in a chronic long-term caregiving situation? What if you're just going through a typical, really tough week at the office?
Well, transient temporary stress impairs the skin barrier just as effectively.
Really?
Yeah, another study looked at healthy university students taking academic exams. Researchers used a technique called tape stripping.
Tape stripping.
They literally take a specialized piece of adhesive tape, press it to the skin, and peel off the outermost microscopic protective layer,
Ouch. Why would they do that?
just to mildly disrupt the skin barrier in a measurable way.
Uh-huh.
Then they use an instrument to measure transepidermal water loss.
Which is what?
It is essentially a fancy way of seeing how fast moisture is evaporating and leaking out through that damaged barrier, how quickly the skin can patch the hole to stop the leak.
Okay, that makes sense.
During exam week, barrier recovery was significantly slower than during periods of vacation, and they found the exact same delayed healing in women subjected to a brief, socially stressful math and speech test.
So, if you're pulling an all-nighter for a massive presentation at work, you aren't just risking a breakout. You are literally leaving the gates open for infection because your skin barrier cannot patch itself up.
Leaving the gates open is practically literal here.
Huh?
We can see the consequences in animal models, too.
Like what?
Researchers subjected mice to restraint stress for just a few days prior to inflicting a small wound. Those stressed mice ended up with 2 to 5 times greater bacterial growth, specifically Staphylococcus aureus, at the wound site compared to the unstressed mice.
2 to 5 times more bacteria.
Yes.
Why does the bacteria multiply so aggressively? What is cortisol doing to the immune response at the site of the cut?
So cortisol actively suppresses the crucial early inflammatory phase of healing. When you get a cut, your body is supposed to immediately release cytokines, specifically things like interleukin-1 and interleukin-8. These cytokines act like chemical flare guns.
Flare guns.
Yeah, they shoot up into the system to call in the first responders, the neutrophils and macrophages, to rush to the site, clear out invading bacteria, and lay the groundwork for new collagen.
So cortisol basically unplugs the radio, and the flare gun never goes off.
Exactly. The immune cells just don't get the signal to arrive in time. The bacteria multiply unchecked. And as we discussed earlier with the TGF-beta pathway, the fibroblasts don't get the signal to start depositing new collagen to close the physical hole.
The entire repair sequence is just paralyzed.
Completely paralyzed.
We have painted a pretty terrifying picture so far. I mean, we've established how devastating cortisol is to our collagen meshwork, how it accelerates cellular aging by over a decade, and how it literally leaves our wounds open to rampant infection.
It's a lot, I know.
How do we stop this rogue foreman? Thankfully, our sources provide a blueprint for fighting back, both on a molecular level and through our daily habits. Let's start with the molecules. The sources highlight specific collagen peptides.
Right.
But I have to ask, every smoothie shop on the corner offers a scoop of collagen right now. Why does the science point to something specific?
Because not all collagen can actually interact with your cells in a meaningful way. The clinical data points to very specific engineered formulations. There is a compelling, rigorous study on AP collagen peptides, which are derived from the skin of the golden threadfin breamfish. These peptides are heavily hydrolyzed.
Hydrolyzed meaning they're chopped up into microscopic pieces.
Exactly. They're broken down into very small molecular chains so they can actually penetrate the cellular barriers rather than just sitting on top of the skin or passing straight through your digestive system.
Okay, that makes sense.
And these specific peptides contain a very high concentration, about 3% of a tripeptide called GPH, which stands for glycine proline hydroxyproline.
Okay, so we have a very specific, highly concentrated, microscopic fish peptide. What did it actually do in the lab?
Well, when researchers exposed human dermal fibroblasts to cortisol, collagen production tanked, just as we'd expect.
Right.
But when they introduced these highly concentrated AP collagen peptides alongside the cortisol, they prevented the cortisol-induced collagen loss entirely.
Just by providing more building blocks to replace the collagen that was being destroyed?
No, the mechanism is far more sophisticated than just acting as replacement bricks. The study revealed that these specific GPH peptides act as glucocorticoid receptor blockers.
They act as blockers.
Yeah, they are molecular antagonists.
Right, they physically block the docking stations we talked about earlier?
Exactly. Think of the cellular receptor as a parking spot. Cortisol wants to pull into that parking spot to trigger the MMP wrecking balls and shut down the growth signals.
Okay.
The GPH peptide acts as a decoy. It sneaks into the parking spot first and takes up the space.
Wow.
So the cortisol floats by, can't park, and eventually leaves without triggering the destructive cascade. The peptides effectively act as a molecular shield against the stress hormone.
That makes so much more sense than just assuming it's a building block, a molecular shield against stress. What other tools do we have?
Well, vitamin C, specifically in the form of ascorbic acid, operates with a dual purpose here.
What does it do?
First, it is an absolute non-negotiable requirement for the enzymatic process that cross-links and stabilizes new collagen fibers. Without vitamin C, any new collagen your fibroblasts manage to build is weak and disorganized.
Like trying to build a brick wall using dry sand instead of wet cement.
That is exactly it. So it provides the structural integrity.
And the second purpose.
Furthermore, clinical trials show that topical and systemic vitamin C helps regulate the local cortisol levels in the skin.
Oh, really?
Yeah, it neutralizes the massive amounts of oxidative stress and free radicals generated by the cortisol cascade. It basically sweeps up the cellular debris left behind by the stress response.
Okay, so we've got AP collagen peptides acting as decoys to block the receptors, and vitamin C stabilizing the new matrix while sweeping up the free radical damage. That sounds like a really solid protocol.
It is a great foundation.
But I have a feeling we can't ignore the lifestyle element. Here's where it gets really interesting. Can I just take a bunch of marine collagen peptides, slatter my face in vitamin C serum, and then just stress as much as I want, pull all-nighters, and skip the gym?
If we connect this to the bigger picture, no.
Darn.
It's incredibly tempting to look for a shortcut in a pill or a serum, but you simply cannot out-supplement a lifestyle that constantly triggers the HPA axis.
That makes sense.
Sleep and exercise are the ultimate systemic regulators. Your skin possesses a very specific, crucial repair window overnight, specifically between 11 p.m. and 4 a.m.
What happens then?
During this window, your body's natural growth hormone peaks, and your systemic cortisol levels are supposed to drop to their absolute baseline.
So if you are lying in bed, doom scrolling at 1 a.m., stressing about the news or work emails, your cortisol is staying artificially high during the exact window. Your skin is desperately trying to rebuild its collagen.
You are actively sabotaging the repair cycle. You are sending wrecking balls into the construction site during the night shift.
That is a terrible visual.
It is. And exercise is equally potent as a regulatory tool. One of the wound healing studies we looked at took older adults and put them on a moderate exercise regimen.
How moderate?
Nothing extreme, just 1 hour a day, 3 days a week.
Okay, that feels very approachable.
Highly approachable.
Yeah.
And the results were profound. Those who exercised healed their standardized punch biopsy wounds 25% faster than the sedentary control group.
25%.
Yes. The regular exercise lowered their baseline systemic cortisol over time and dramatically improved the immune response, those cytokine flare guns we talked about, at the wound site.
The peptides might protect the skin fibroblasts locally, but if your whole body is constantly on fire with stress, your barrier function will still suffer.
Exactly.
Your wound healing will still be delayed, and you'll still be accelerating your biological clock.
Right, because systemic chronic stress generates widespread inflammation and immune dysregulation. You have to combine the foundational nutrition and those molecular shields with actual systemic stress reduction.
So prioritizing that 11 p.m. to 4 a.m. sleep window.
Yes, and getting regular exercise.
Mm.
That stops the systemic flood of cortisol at its source before it even reaches the skin.
It's really about attacking the problem from both the outside in and the inside out. You have to shut down the rogue foreman at the top level while simultaneously protecting the construction crew on the ground.
It is a comprehensive biological system, and, understanding the mechanics gives you the actual power to protect it.
So, to synthesize the journey we've been on for you today, the connection between your stress levels and your skin isn't just cosmetic, it is a profound biological reality.
Yeah.
Cortisol acts as a wrecking ball to your collagen scaffolding, actively destroying existing structures with MMP enzymes while halting the production of new collagen by suppressing TGF beta. We've learned that this chronic stress shortens telomeres, aging your cells by over a decade, and it severely impairs your body's ability to heal physical wounds by unplugging the immune system's flare guns.
Quite the list of casualties.
It really is. But you have actionable tools. Interventions like GPH-rich collagen peptides can steal the parking spots to block the receptors, vitamin C can cement the new matrix, and protecting your sleep and exercise routines can simply turn off the cortisol faucet.
The science provides a very clear roadmap for recovery.
It really does.
Yeah.
But before we wrap up this deep dive, I want to leave you with one final, incredibly provocative thought drawn directly from the research.
Oh, this part is wild.
We talked earlier about how the skin has its own local stress system, manufacturing its own cortisol independent of the brain. But the sources note something even more specific, and honestly, a bit mind-bending. Your skin actually contains a specific enzyme whose sole job is to convert inactive cortisone into active cortisol right inside the skin cells themselves.
It's a localized conversion mechanism. It operates completely independently of what your brain or your adrenal glands are doing in that specific moment.
And what this means is that long after your stressful week is over, long after you've closed your laptop, logged off, and your brain finally feels relaxed, your skin might still be caught in a localized chemical panic attack.
Right.
That enzyme could still be churning out active cortisol directly into your dermal tissue while you sleep. So the next time you look in the bathroom mirror after a grueling week and notice your skin looking tired or broken out, remember this.
Skincare isn't just cosmetic.
Exactly. It is about actively communicating safety, repair, and recovery to an organ that literally remembers your stress.
A very powerful reminder to treat our bodies and our skin with the grace and protection they actually require.
Absolutely. Thanks for taking this deep dive with us. We'll catch you on the next one.